Hello everyone, my name is Wang Shaofeng. I'm from Beihang University. Today I will introduce my thesis to you. The title is AspIOC, Aspect Enhanced Deep Neural Network for Actionable Indicator of Compromise Recognition. My report will be divided into three parts: background and situation, our method, conclusion, and prospect. First, I will introduce the background and situation to you. Threat intelligence describes threats facing or brewing for assets. The picture on the right is a sample. With the help of threat intelligence, early detection, advanced understanding, and rapid response to network attacks can be achieved. There is a requirement that we need to recognize the indicators of compromise in threat intelligence. So what is the indicators of compromise? Indicator of compromise, IOC for short, is a technical indicator defined in the long-term practice of digital forensics that can reflect the behavior of a host or network. Although IPs, domain names, and other indicators have a specific structure and can be extracted using regular expressions, but the threat intelligence text contains no malicious IPs and domain names. Such as references, we need to recognize whether the IP and domain names extracted by regular expressions are IOCs. For example, there are two sentences. The first one includes an IOC, while the second one does not. Researchers have mainly used two approaches to solve the recognition problem. The first is based on the text classification model. They recognize the IP and domain name extracted by the regular expression through the thematic information of the sentence. The second is based on entity extraction model. They define the IOC as a special entity for extraction. But existing solutions do not use specific information of threat intelligence, and the effect needs to be improved. Next, let's discuss our method, AspIOC for short. The IPs and domain names extracted by the regular expressions are mixed with non-IOCs. We need to identify and filter these noise samples. The features of the problem include 2 points. First one is the character level feature of the IOC. Part of it will be invalidated. Part of it is generated by a random algorithm. Second one is that most of the sentences where the IOCs are located describe the attack behavior with malicious tendencies. Based on the 2 points, we model the problem of recognizing malicious IP and domain names as a text polarity classification problem based on aspect words, where aspect words are IP and domain names in sentences. In AspIOC, the embedding layers convert the sentence and aspect terms to embedded vectors. We then feed word embeddings and the char embeddings of the aspect term into the interactive feature extraction model and the contextual feature extraction model to generate two vectors, which are rich in semantic information. We also feed char embeddings into the character-level feature extraction model, which outputs 3 character composition feature vectors based on different attention mechanisms. The 5 vectors in the output layer are then combined and spliced into one vector, which is used to get the classification result of the model. We will further describe these 3 feature extraction models in the following parts. First, I will introduce the character level feature extraction model. The input K is a matrix of character vectors for IP and domain names. We use three attention mechanisms, including dot product, bilinear, and MLP, to calculate the weight value called weight score. Then we use the weight value to perform weighted fusion on the matrix K, and finally get three features as output. This is the structure of the contextual feature extraction model. The output of the model includes two parts. The left half is the encoding of the whole sentence semantics by Distilbert. The right half combines the position of the aspect term with the feature extraction result of Distilbert. Interactive feature extraction model is composed of 8 basic blocks in the dotted box, and the aspect terms embeddings and the context word embeddings are input into the model as two independent parts, and the deep interaction is made through the attention mechanism. We collect the data for constructing our dataset through an open web platform. Part of the dataset is obtained from major security websites through crawlers, and the part of it comes from manually downloaded English short text dataset. After using regular expression and VirusTotal, a website for identifying IOCs, about 50,000 IOC samples and 50,000 non-IOC samples are obtained. In the experiment, we use accuracy, macroFE, and the number of trainable parameters to evaluate the model. The proposed IOC recognition algorithm, AspIOC, is compared to the state-of-the-art models on the aspect-level text classification tasks in the above table, including TNET-LF, AOA, and MGAN with attention mechanism, BERT-SPC, Roberta SPC with pre-training model, and ASAWD with both pre-training model and the graph neural network. Our model achieves the best results. Ablation experiments are performed on the three parts of AspIOC using a step-by-step superposition model structure. In the table, attention represents the attention-based character-level feature extraction model. Interactive feature represents the interaction feature extraction model. The BERT represents the Distilbert contextual feature extraction model, and BERT represents the replacement of the Distilbert with BERT base. We can see that the combination of attention, interactive feature, and debert achieves the best results. We applied three attention mechanisms in the character-level feature extraction model to verify their effectiveness. The dot product works best when the mechanisms perform alone, and the experimental results of the two combinations are relatively the same, and the combination of the three mechanisms achieves the best results. Finally, let's talk about the conclusion and prospect of our thesis. In this thesis, in order to accurately identify meaningful IOC in unstructured threat intelligence tests, an aspect enhanced IOC recognition, a model IOC is proposed. For the first time, we introduce aspect-level sentiment analysis into the investigation of IOC recognition, inspired by the compositional characteristics of IOC characters. and the crucial role of IOCs in the semantics representation of the threat intelligence text. AspIOC uses DistillBert to obtain the IOC contextual semantic features, integrates threat attention mechanisms to extract IOC character-level features, and also obtains interaction feature from these two kinds of features. We cracked about 100,000 samples using an open-source web platform. Experimental results shows that the recognition performances of AspIOC is better than that of the state-of-the-art IOC recognition and text classification models. Future research on the IOC recognition systems will focus on more complex scenarios, such as IOC detection in unstructured threat information like images. Thanks for listening.